So these are two projects that were built for the Fisk Planetarium. They're exhibits in their lobby. And I want to talk about a couple of the software tools that I developed in order to make visualizations for these pieces. So the first one is just this cube. It is a simulation of the cube. We didn't actually have it finished when I started making visualizations, so I needed sort of a proxy. And so that's where this came in. And so right now the simulation isn't showing too much. It's just the RGB color space. And really this is just a good visualization of how each individual sphere here corresponds to an LED in the final cube. Now, coloring each of the individual spheres or LEDs by hand or by algorithm is pretty time-consuming and can get very convoluted. And so I wanted to come up with a way to better be able to create animations and use more recognizable objects. And so this, what I'm showing now, is a .obj file. It's just how 3D files are stored. And I wasn't really sure with the format of these files, and so I built this program that we're going to see here in a sec. And so I built this program to iterate through those files and draw all of the vertices very slowly so that I could see the progression and see how the file was stored. And so in this case, the rocket, the Saturn V, in this case, happens to be stored upside down. It's not something I would have necessarily known just by sort of looking at the data stored in the OBJ file. But since I have this software now, I could work out different algorithms and find the most efficient way of displaying these objects on the cube. And so by taking what I learned in the other program, I could then use those algorithms developed to iterate through those OBJ files and map them onto individual spheres on the cube. And so the last piece of software that I want to talk about is the tool that I wrote in order to put visualizations on the surface of the solar arcade. Now, the idea was that it would be a replica of the sun. And we wanted it to have the same feel as the surface of the sun. And so looking at the image here on the left, this is an actual photograph of the surface of the sun. And then on the right is a visualization of something called simplex noise. Now, simplex noise isn't a perfect replica of the sun, but I think visually they have that same sort of flux, that same sort of flow. And given the resolution that we're working with, it fits on the arcade. I wanted it to generate in real time, and that's why this is using an algorithm rather than a video. And the reason I wanted that is as the viewer is walking through the arcade, there are infrared sensors that start to create sunspots that we can see here. And so again, that adds to this real-time generation, and that the viewer is actually controlling and interacting with the piece and with the simulation. And so that's just some of the software that I wrote for these two pieces. A lot more went into actually displaying them on the pieces, but for these purposes, I wanted to show these kind of visual tools that I was using in order to create these visualizations and create this software.